Hello, and welcome to MVAO103 Auto Operator Configuration. This is Part 3. MVAO103 is the third in an 8-part series of courses covering Auto Operator. Auto Operator rule sets are stored as PDS members in the UBB-PARM library. These members have two different nomenclatures for naming. The first is AAORULXX. This is the original format of the members when they were distributed with Auto Operator, and it's also the format for any rules that we distribute the product to support solutions. The second format is RUL followed by 5 characters. This is the current standard for naming rules, and this is what we recommend that you do for your rule sets. One thing to point out is you should never change your rules via ISPF edit. It's okay to browse them that way, but if you need to make updates, always use the rules processor. Auto Operator ships with several rule sets to support solutions delivered with the product. The first one is AAORUL00, and this is generally a sample rule set that provides models of rules that you can use to build your own. Our recommendation is not to enable the rules in this rule set, with the exception of the alarm start and alarm stop rules that will generate alerts for exceptions generated from MainView Alarm Manager, although these only apply if the BBISS does not have alert receive equals yes. There's also an AAORULBQ and AAORULBH that contain MQ rules for support of the distributed MQ solutions with Auto Operator. There's an AAORULBA that traps and start and stop messages for your all TP regions. It also will initiate an exec with the same name if it encounters that event. There's an AAORUL D1 through D8 for DB2 solutions, AAORULC1 for CICS solutions, I1 for IMS solutions, and then for MVS solutions, it's M1. Now, there are 4 rule sets that are out there for CSM. They're AAORULBC, BD, BE, and BG. You should never update these. They're all managed internally if you're using the CSM solution. With Auto Operator version 8.1, we introduced the notion of a rules registry as an alternative to using PDS members. This provides you with a new application that provides some advanced administrative functions. We've centralized a repository so you don't have to worry about integrity across the Sysplex. You have the ability to deploy your rules across the Sysplex. And we have an all-new Windows interface that you can use in the graphical interface MainView Explorer. With this implementation of the registry, there is a bit of a paradigm shift. Instead of rules and rule sets, we now have rule pools and set bases. You cannot use the rule registry. If CSM is active, you need to be migrated over to MainView Tom. And there is also a new PARM member to support the registry, AAOPRMxx. It will have a default of 00 for the suffix, and by default, the rules management application is turned off. Now let's take a closer look at another important PARM member, AAOPRMxx. We have several parameters we can specify in there, so we're going to break them out into different areas. The first regard how you want to do your rule set management. You can specify rule save equals first, original, or prompt, and what that indicates to Auto Operator is where you want this rule to be placed in the rule set when you save it. There's a rule protection equal yes or no that provides you with some NQs at the rule level, and there's a rule set protect yes or no, which will provide NQs at the rule set level. And this can help with serialization across your LPARs when you have multiple people making updates to Auto Operator rules. AAOPRM also contains some parameters related to MPF processing. Honor MPF equals yes or no indicates whether Auto Operator will see messages that would normally be suppressed by MPF. Our recommendation is to set Honor MPF to no so that Auto Operator does have the opportunity to process all of the messages. The second is the MPF filter, which says how you want to handle the messages if they're being passed to AutoOperator. You want to use the default values for this keyword, and then AutoOperator will see all of the messages and you can perform automation as you see fit. If you don't want that message to come out in the console, you can, of course, build an AutoOperator rule to suppress those messages. And the last parameter on this slide is the suppress reply parameter, which suppresses any of the text that you pass to a reply in a WTOR. AAOPRM also contains parameters related to MQ processing. MQEV equals yes or no indicates whether we want to automatically enable the instrumentation events for the queue manager. If we're not capturing the instrumentation events, then there will be no rules being fired for that queue manager. So our recommendation is to set this value to yes. MQGINHIB, MQ inhibit, says how do I want to handle this queue when the get is disabled. We can specify journal to write a message to the AutoOperator journal. WTO will write it to the console. We can ignore the event altogether, or we can use alter to update the queue definition to have get enabled. Now our recommendation is to set it to journal so we capture the message as an audit, but then you also want to write a rule for it. And you may want to use it for notification, or maybe you want to do some other things and then alter the queue. And then similarly, MQ and share has the same types of options. And this is in case of a queue is set to no share. We need it to be shared so that we can do processing. And here you can specify how to handle that situation. Let's take a few minutes to talk about exec processing in AutoOperator and some of the configuration options that are related. First thing we need to talk about is the way AutoOperator processes execs. And he has three different queues for processing execs. There's a high priority queue, a normal priority queue, and a hot priority queue. Now, there are only two types of exec threads, right? We have high priority threads and normal priority threads. So only the high execs will run in the high threads, and only normal execs will run in the normal threads. If you have something in a hot priority queue, that means it'll go to the next available thread in either of the queues. UBB power member AAOEXPXX contains parameters related to exec thread processing. The first is max norm, and this indicates the number of concurrent normal priority execs that can be running under AutoOperator. Max high indicates the number of concurrent high priority execs that can be run. If you're using AutoOperator to manage your IPLs, you may want to set max high equal to 10 to allow for a high number of concurrent execs to run. There's also a setting max hot queue, which indicates the maximum number of hot priority execs that can be queued. And you can also specify exec equals to the name of execs to set them as high priority execs so they run in the high priority queue. AAOEXP also contains parameters related to the queuing of the execs. Max norm queue sets the maximum number of normal execs that can be queued. The default is 0, which says there is no limit. We strongly recommend you set it to some value. Usually between 20 and 50 is more than enough. The second is max high queue. Again, its default value is 0, which says there's no checking. Set it to some value. If you're using CSM to manage your IPLs, you probably want to set this to 100 to allow for a lot of queuing while things are trying to start up or shut down. And then there's a warn level 1 and a warn level 2, which you can use to generate exception messages when your exec thread queues are becoming full. Now the warn level 2, we do suggest that you may want to set it to 99%, so you'll get a message whenever you fill up your exec queues, and you'll know you need to increase the size. Additional params in AAOEXP include UC params equals yes or no, which says, do I want to translate to uppercase the parameters I'm passing to my execs? Now we can specify no to have mixed case, which can be very helpful for those areas where you have mixed case entities, such as MQ series or Unix system services. There's also an audit message equals yes or no. that generates messages in the journal anytime someone does a rebuild of the exec library or runs an exec from the terminal session. We do recommend that you set audit message equal to yes, and there's a sub-X auth that allows you to specify how to handle security checking for batch jobs that run AutoOPERATOR execs. Remember, AAOEXP also contains some parameters related to exec processing. The first is PEREXLIM, and for this one we suggest you do not use it, so set it to a value of 0. What it does is it collects the maximum CPU percentage for an exec in a 15-second interval, which is probably not what you want to report on for excessive exec processing. Instead, we suggest that you use the time EXLIM value. And here what we're capturing is the maximum total CPU time consumed by the exec. If you exceed that value, the exec will be canceled and it'll be returned with a user 3001 append. For this value, 5 seconds is generally okay. You need to consider how involved your execs are and how long they run to set a good value for this. We also have some values we can set for control and appends, but you can take the defaults and everything will be probably what you expect it to be. In AAOEXP, we could also specify some TSO RexParms, the TSO timeout for TSO commands that you call from your execs. There's a max tput to indicate what the maximum number of journal messages you can issue. You can set a default unit name, as well as setting a prefix for your DSNs. There are also some definitions you can use for OSP, which is the Open Systems Procedural Interface. It's generally a screen scraping technology that comes with AutoOPERATOR, and here you define the ACVs that you want to use for that processing. I'd like to make a few points on exec performance. First, we need to consider the number of concurrent execs or threads. Each of the execs runs as a separate TCB, and the maximum number of Rex threads we can have in TSO is 18, at least as distributed by IBM. That value can be changed by reassembling a module to modify that value. All the execs that run actually run in the OS with the same priority of 156. There is an AutoOPERATOR function you can use to change the priority of a single exec, but they're all going to by default run in the same priority, whether they come in the high queue or the normal exec queue. Important to point out that the BBISS should run in the service class sysstc. That is the case in most shops, but you may want to confirm that's the situation in yours. One way to improve the performance of your execs is to use VLF. And VLF is the libraries are defined in MVS, not in AutoOPERATOR. And what will happen is the execs themselves will be tokenized and stored in a database, which will reduce the amount of CPU that will be needed to process the execs, as well as the disk I/O since they're now in a data space instead of sitting on disk. And these are defined in Sys1 PowerBlib in the COF VLF member. And here's a sample of how you might define some of the libraries. You may also want to consider the asynchronous processing of your execs. If you use IMF select exec with a wait no, the exec itself that you're making the call from will run faster because he's not waiting, but you potentially run more threads, which can introduce more overhead. You can also want to consider invoking Rex calls versus IMF select exec calls. The Rex calls are synchronous, like using a wait yes. You can pass parameters. They have the same program stack as you would have with an IMF select exec. But the called exec does not have access to any of the IMF variables populated by AutoOPERATOR. It also has more overhead. So our strong recommendation is use the IMF exec select exec statement as an alternative to Rex calls. You also want to maximize the use of extended MCS consoles, and you can do so when you use the IMF exec command by enclosing the command itself in single quotes. If you don't do that, then it's going to use the MCS console. So always include your command in single quotes. There are several ways we can determine the overhead of your execs. You can use the display BBI command in the journal. You can use Rex functions such as time E. You can use AutoOPERATOR's Automation Reporter, which provides some additional information about exec performance. You can look at the Exec Manager application in AutoOPERATOR and see what those statistics look like. And you can also capture the TCB information from MainView for ZOS. UBB Power Member AAOALS contains parameters related to processing alerts. The first is max store equals, and this is where we set the value that defines the maximum extended private that we can use for our alerts. We do suggest that you set this to some value. If you don't have anything to start with, I would suggest 128 as a starting point. If you're going to have lots and lots of alerts, maybe you want to go 512, but 128 should be plenty. You can also specify warning levels for when the alert queues are getting full. So you can specify warn level 1, set to some value to let you know that you're filling it up. And then there's a warn level 2, which you may want to set to 99, so you do get an exception when the alert storage limit's exceeded. Now there is a value alert NV that allows you to specify whether your alerts are to be retained over recycles. And then there's a publish keyword that allows you to indicate how you want alerts to be published for our off-board solutions. If you wish to accurately size your max store from the previous slide, you can do so from the Alert Queue Statistics view. If you look at the total size field, you can create a sum of all those values, and that will indicate how much max store you will need for your alerts. UBB Power Member AAOMQL contains parameters related to MQ processing, and this determines which queue manager will be populating events into AutoOPERATOR. So we have one line for each queue manager, and we can say we want to include or exclude a queue manager, and then the associated queue with that queue manager. UBB Power Member AAOGME contains parameters related to AutoOPERATOR's ability to send events off platform. The first set of parameters we'll need are for the BPPM server. We'll need the IP address, the port number, and the host name of that server. And then we'll need some additional parameters. We'll need the host name of the MVS system. We'll need to indicate GME act equals yes to turn on the interface. Then we'll need a connection to MainView Explorer, so we'll need its host name and port number. And then we'll need to provide a configuration file for BIM. And if we want to enable the BIS interface, then we'll need to set BIM equal to yes. This concludes MVAO103 Part 3.